Good morning, students. Today we will study refractive index in detail. Now, you remember from my previous video, we studied Snell's law of refraction. Snell's law of refraction says that sine of I upon sine of R is a constant value, which is known as refractive index. Now, consider here this figure, medium 1 and medium 2. Let me consider medium 1 as air and medium 2 as glass. This is the incident ray which falls on the interface of medium 1 and medium 2, making an angle I, and after refraction it makes, once it gets refracted, it makes an angle R. So R is the angle of refraction. So the ratio of sine of angle I and sine of angle R is a constant. This constant is called the refractive index of second medium with respect to the first medium. Please make a note of it. This constant is the refractive index of second medium with respect to the first medium. Now, what does this refractive index gives? The physical significance of refractive index is given here in the form of following points. See, refractive index gives the relative speed of propagation of light in different mediums. That is, it gives the extent to which the bending will happen, that is, whether away from normal or towards the normal. Refractive index for a given pair of medium depends upon the speed of light in the two medium. So, here this ratio is basically giving you the ratio of the velocities or speed of the light in a medium. Refractive index of any medium gives the ratio of speed of light in vacuum to the speed of light in that medium. Here, so I have written here in this form, Nm stands for refractive index in a medium. Speed of light in air or vacuum, that is C, its value is 3 × 10⁸ meter per second, upon speed of light in the medium. So I am writing it here as V, where Nm is the refractive index of a medium, given medium. C value is 3 × 10⁸ meter per second. Now, for example, if I say that the refractive index of water in water is 1.33, what does that mean? This means that the ratio of speed of light in vacuum and the speed of light in water is 1.33. So I'll substitute here in this formula. In place of Nm, I'll write here N water, that is 1.33, speed of light 3 × 10⁸ upon speed of light in water. So in this way we can also find the speed of light in a particular medium. So greater is the refractive index, more optically denser the medium will be. So in general, the refractive index of medium 2 with respect to medium 1 is given as N21, that is equal to speed of light in medium 1 upon speed of light in medium 2. Students, please make a note of it. The refractive index of the medium which we are investigating will be in the denominator, with respect to medium 1 will be in the numerator. By the same argument, the refractive index of medium 1 with respect to medium 2 is written in this way, that is N12, speed of light in medium 2 upon the speed of light in medium 1. The refractive index of medium with respect to vacuum is termed as absolute refractive index or simply refractive index. So, if we come to the mathematical formula, N medium, that is refractive index in a particular medium, is nothing but the ratio of speed of light in vacuum upon speed of light in medium. So it is written as here, N is equal to C by V. Now we have this formula and we are in position to solve some questions. But before I start with this question, I would like to draw your attention on this table which is already given in your NCERT textbook. This is table 10.3. Here the refractive index in various medium is given. You can see here air has refractive index 1. It is approximately equal to 1. It is 1.0003, which is very much equal to 1. So the speed of light in medium air with respect to vacuum will be 1. That is, it is always the same. You can see here the following mediums are placed in the increasing order of the refractive index. So far, it is silicon carbide which has the highest refractive index in visible region. As you all know that the refractive index varies from color to color, that is from wavelength to wavelength. So the refractive index is different for the visible region and it is different for the other wavelengths. So for the visible region it is the highest, it has the highest value. All these values are given for the visible region only. Now since we have this formula, we are in position to solve this question. So to start with, the light enters from air to glass having refractive index 1.5. What is the speed of light in the glass? I told you we are already familiar with this. We know its value is 3.8. If we know the value of the refractive index, we can always find the speed of light in that particular medium. So what is the speed of light in the glass? The speed of light in vacuum is given as to be 3 into 10 power 8 meter per second. In exam, this value may be given or may not be given, so you have to remember this value. So here first of all we'll start with given c, that is speed of light is 3 into 10 to the power 8 meter per second. This is already known to you, and n is given to be 1.50. What do we have to find is the speed of light in the medium v, right? Now we know n is equal to c by v, so we'll simply substitute the values. 1.50 is equal to 3 into 10 to the power 8 upon v, or v is equal to 3 into 10 to the power 8 meter per second upon 1.5. So this comes out to be 2 into 10 to the power 8 meter per second, right? So we see the speed of light in the glass is less than the speed of light in the vacuum. So when the light will travel from air or from vacuum to the glass, the bending will happen towards the normal, right? Because the speed has reduced, speed of light has become less. So I hope you have understood how to use this formula, n is equal to c by v. I repeat, refractive index gives you the ratio of speed of light in a particular medium with respect to the speed of light in vacuum. Thank you so much.